Okay, so let's motivate a certain coordinate transformation as a way of trying to understand further the nature of this strange radial location, 2gm over c squared. So if we say, look at this combination of speed of light times t, or that could be 1, and in this case this would be t, plus x, so we're just in xt space. So we're back in special relativity, t or ct, I'll put that there. Let's choose some value of v, say v is some positive value. I don't know, v is some positive value here. So, right, that's some value along the x. So let's say that at t equals 0, so at t equals 0, right, we have x is equal to v, and so there it is. This is t equals 0. At t equals 1, we have x equals v minus c. Right, at t equals 2, we have x equals v minus 2c, and so on. So we are subtracting from this value of v as time passes. So, we could be here. That could be t equals 1 and t equals 2 here. We're moving like that. And so this represents an object that obeys dx by dt, right, is equal to, so x is equal to v minus ct, and dx by dt that's a constant, minus c. So we could also tell by the slope on this diagram that this represents light moving to the left on the space-time diagram. And so we want to take advantage of this by defining, and so we should maybe point out that, v could have different values. So for the infinite number of values that v could have, we could make v greater than that, and then that would represent speed of light moving to the left, starting from there, and so on for higher values of v, and so for lower values of v. Of course, there's nothing that stops us from going to negative times, and so all of the light paths in space-time to the left in this one-dimensional universe are captured by this expression. And so we can think of v as some coordinates whose different values represent light paths. And so in the space that we care about, it's t and r, where the r has a radial coordinate. So that represents, time is passing and distances that are traveled in that time. So by analogy, we have c times t plus the distance that you travel in the radial location, because we want to now think of light traveling in the negative radial direction. But this, the corresponding distance in the RT space involves integrating dr over 1 minus 2 gm over c squared r square root, right? So this is the quantity that gives us the distance, and so when you integrate that, we get, what do we get? We have r plus 2 gm over c squared, the natural log of RC squared over 2GM minus 1. And so this is going to represent light moving in the negative radial direction toward this region, R equals 2GM over C squared. And so our next goal is to look at casting the metric, not in terms of T and R, but this is an R, not in terms of T and R, but in terms of V and R, and that will give us some insights into what's going on with light as we cross that region that before we didn't have access to because the light cone was closing in on itself.